audio test. Hey guys, welcome to the stream. I'll be going over how to use the credits API. I guess some of you guys know me in the community by my Telegram handle, Zella101. I'm a developer from New Zealand who has had an interest in blockchain technology for the last 2 years, and I've tested a few different products, credits being one of them. So I'll go into how to connect. So I'll go into how to connect to a node to call the credits API. I guess the node's API is Thrift, and it's exposed over port 9090. So to ensure you can connect to the API, you need to make sure that you've got a rule added to your firewall, and if you're behind that, make sure you also port forward. And also make sure the node you're connecting to is fully synchronized. So now going into generating a Thrift API wrapper. So what we need to do is on Credits GitHub, there's a repository called CS API, and that is what you need to be able to compile all the Thrift files down into pretty much the code files you need, so all your classes and everything. And I'll show you where you can get that link. So this is it right here. So all these files here, you'll need to download all of these. And I guess I should actually go into what can you do with the credits API. So with the credits API, it's pretty much the core interface to communicate with pretty much the credits blockchain. It allows you to send transactions, monitor transactions, connect your dApps, up so you can call smart contracts with it. And also Thrift API allows you to generate the code files into various different languages. So what we should do is, once you copy all of these files, if you want to use the credits API, copy all of these files here with .thrift, and you also need to go over to Apache Thrift, inside Apache Thrift, where you'll need to download a copy of Thrift, and so these are the files that you can get for it. Let's go back into my slide. So also some language packs need to be installed. I've made a little demo in C#, but to actually generate the C# classes, you will need to install the mono develop package before you can actually generate the class. So I can actually probably show you how to do it. Okay, so the CS API master is pretty much CS API. So these API.thrift files are what we're going to use, well, what Thrift needs to be able to generate your class files. So that's pretty much your wrapper that you'll interface through C#. And so once you've got Apache Thrift installed, then you can do something like this. Was it? That's correct. And then it should create a folder called gen C#. And if we go into here, cd gen C#, cd node API, then here's all your class files it creates for you. So this is what you'll pretty much include in your C# project. And once you do that, you will have something like this. I'll just go on to the next slide, because there is also some components that you should also have if you're there's also some three main components you need to really use with the API, and that's the Apache Thrift library, so that can be installed as a NuGet package. An encoding library, so you can encode and decode public and private keys, so that's just base 58. So actually the pull, I'll ask your questions if you have some as well. So the keys are stored as base 58, so they're just kind of binary byte arrays, but the actual the pool hashes are just hexed. So I'll go into that later. So it's just a base 16 of the pool hashes, and also elliptic curve digital signature library. So you probably won't want to program that yourself since it's already out there. Base 58, you can probably program that easily enough yourself. But you will need to include the Apache Thrift library. You'll need some type of base 58 conversion, and the elliptic curve digital signature library. So in my demo, I used a package called Simple Base, and that handles base 58 encoding, and also Chaos NaCl, and that handles elliptic curve digital signature algorithm. So it's ED25519. I think I don't rush through any of this too bad. Okay. And I'll quickly go through the API calls. Yeah, so make sure if you're going to if you want to use the API, you come over to the GitHub here. And I think they're continuously working on the API still, but you still should be able to use it. API description. And this looks like pretty much just the signatures for every class. And this is pretty much all the API calls there are. So balance get, that will get your balance from a node. So you have to connect into a synchronized node, a fully synchronized node, to use these API calls. Balance get will return your balance with the address you use. Transaction get, that will get a transaction. Transactions get, that will get multiple transactions, and that can also be paged, so you can use an offset with a count. Pull, get a pull. There's a whole lot of different calls you can use. Some smart contract calls. Once get, transaction flow. Transaction flow is the main method you need to call to send a transaction to the network. And I'll actually go over some of the parameters you need to add in there. In the simplest terms, how can this be used? Well, if you want to do anything on the blockchain, on the credits blockchain, you'll have to go through the API. So if you want to interact with a smart contract, if you've got a DApp, well, you'll need to pretty much call one of the smart contract methods to be able to execute that smart contract method. Or if you want to, say, view all your transactions or automatically send transactions to someone, you can automatically do that. I guess in simplest terms, how can this be used? It's pretty much just the same as if you're going to interact with the API of any other blockchain. So it can do everything any other blockchain can do, and it's pretty much the main interface you need to use to be able to communicate with the blockchain, to receive information or to send information. So there are quite a lot of API calls you can use, so it's good to have a look over them all. And we'll go into the demo, because this is where I can kind of show you some stuff actually being used. Alright. So say here, it's actually really easy to use. I can say get balance, and I've got my public key, and that's just this key here, that's base 58 decoded, so it's a byte array, and that's what balance get takes, and the 0 is actually for the CS currency. So if we run this, I'm going to breakpoint here, so we'll just see the balance. So here's the wallet I used, and here's the balance. So HP, TD, and it's quite a big balance because I'm using a wallet with quite a lot of CS. And this is the wallet right here. So we can kind of compare these results with each other. And then we might want to get, say, 5 of the past transactions. So we'll run this transaction get, and that takes in the public key as well as a byte array. And this is where to start at, and this is a count of how much to return back. So we want to start at the last entry. So all the transactions are all in descending order. So it will take the last transaction that was sent first, and then return all of the other ones in descending order as well. So if we have a look at that, we can have a look at the transactions and see the last 5 transactions that we got. And then we can create a transaction. So if we create a transaction, we'll say we've got 3 in now. Let's change that to 5. Just coming out these. And here's the result here, success. Have a look over it. Here, should see 5 being updated. Alright, 5 CS. So that's me using the API to send transaction to the node. So I'm using the API interface of the node, and that's pretty much bubbling it out to all the other nodes and added to the blockchain. And now we've also got a whole list of other. Okay, I'll actually go through how we create the transaction. So here's the transaction object. For the ID, I used pretty much epoch time, current epoch time in milliseconds. The source is, of course, a public key. Target, I got the target public key here up here as well. And I just added these little quick methods here to convert it into a byte array for me. And the amount is so the first part is the whole number, and this is the fractional part of the number. And Credits uses that to pretty much store large numbers on their blockchain. Yeah, so I think I call that an integral and fractional part of the amount. The balance is actually, the balance field is the total balance of the wallet. So this is what we got here earlier. And I think this field here is the balance field here is just for debugging at the moment. I think they will probably be removing that later on. I'm not 100% sure, but I think they'll be removing it later on. And the fee, setting a fee, it still generates a fee, so this field doesn't actually matter at the moment either. And the currency 1, that just means CS, and that's just a byte. And I guess if you're wondering why do they use the Thrift library to send data to the nodes, well, the Thrift library is actually quite compact, so I should actually show you. I've got a transaction generator I created for credits that allows people to test the transactions per second, and I actually construct the raw Thrift packet through that to send. So I don't actually go through the API when I'm in my transaction generator, but will the balance be public access and what protects the private keys? Will the balance be public access? So the balance of the wallet, it's a public blockchain. So if that's what you mean, it's a public blockchain, so anyone can see the balance of any wallet. And what protects the private key? Well, you shouldn't be handing out your private key anyway. I guess what you're saying is, yeah, you shouldn't be handing out your private key anyway. So if this was a D app, then you would probably ask the user to put in their own public and private key, and they would be running that D app off their wallet. So yeah, I think, does that answer your question, or? That's what I mean. No, what encryption is on the private key stops people hacking. What is on the private key? So you don't actually expose the private key, so the private key never goes across the network at all. The private key is only used to assign the transaction signature. So no one should be able to access your private key unless unless some malicious kind of software has unless someone's generated some kind of malicious D app or something where when you put your key in, it sends it back to their own computer or something. But no one should really have access to your private key. It doesn't get sent through. No reverse engineering like through HD5 hashing. Stop people accessing your private key. No reverse. See, no one. I'm not sure if I'm understanding you, but no one should ever have access to your private key, and the only thing your private key is ever used for is just to sign this message. So the only thing that the private key will be is in this application. No one outside can see it. It doesn't travel through the internet. It's plainly used to build up this we build up this all the fields here and sign them all and add them to the transaction, and then the blockchain checks that signature against the transaction fields to see if it's a valid transaction, and that's pretty much what happens. So you never actually send your private key through the internet of any sort. It's always just a signature, a hash of the actual transaction. Yeah, so this, okay, how is the public key generated? So they used some, what was it? Hold on. So I forgot that it's a pub private key. I'm not sure on the exact algorithm. I don't think it's RSA. It's RSA. Hold on. I've got it in here somewhere. Generate key pair. Okay, so it's actually the elliptic curve algorithm generates the public and private keys. Yeah, it's elliptic curve, isn't it? Credits is using Blake 2 hashing. So when the transaction is sent to a local node you are running, the node hashes it and sends the transaction to it. Yes, yes. HD5 encryption. I don't think it's, I'm not sure if it's HD5 encryption. Credits uses Blake 2s hashing. HD5. Yeah, I haven't really heard of HD5 before, unless I guess if someone in here knows, but I think he's saying to generate the public and private key. I think it's just elliptic curve generates the public and private key. Elliptic curve generates public and private key, and Blake 2 is used for yeah, hashing. Or I've seen those problems for reverse engineering the public key to find what. See, the algorithms they're using to actually test it with, a lot of other blockchain companies are doing using the exact same algorithms. So I haven't heard of a problem like that with the reverse engineering the public key to find what the private key is, and we're changing the encryption to prevent this. I'm not sure, but I haven't seen anywhere that. Okay. All right. Well, I'll continue anyway, but I guess someone else from credits can answer that if they want, but I'm not understanding too well what you're saying. Sorry. And yes, so I guess this is the demo here. And do you guys have any other questions? What other questions do you guys might have? I'll also go through the kind of transaction generator. So this is a little generator I used. Well, I built to pretty much test the credits network load. And this is a raw Thrift packet I'm just generating here, so this is not even going through the API. It just shows the kind of compressed format that credits uses. Of course, this is a lot more lightweight than something like sending JSON or. Can you explain the other use cases on the blockchain? So the blockchain's use cases on the blockchain's more of a way to decentralize, say, decentralized stuff. So if you want to, say, have notes that never go away, like if you want to create a messenger, a blockchain messenger, and you're worried that you think someone's going to delete your messages or something like that, or they're going to get removed for some random reason, well, you can use a blockchain to pretty much post your messages on, and it's pretty much immutable. You can't really change anything from it. Once it's on there, you can't take it off. There's actually quite a lot of companies coming out these days to use blockchain. So you've got, you're probably going to find it in like logistics and all different types like that. Any other questions? See, this little function I had in my transaction generator, that generates the key pair. I actually haven't used this in a while, so I'm not 100% on everything it's doing at the moment, but yeah. So anyone, oh, and I'll go through a list of the API calls as well, so you can see that a little bit better. So we got balance get, we got get last hash, pull info get, pull list get stable, pull transactions get. Here's some smart contract ones. Smart contract addresses list, smart contract get, smart contract all list get, smart method params get. I guess also in the later webinars you'll also be able to see how to actually use the API to call smart contracts. That might be when the API and smart contracts, like a DApp demo or something. Is there an API to get all the transactions from a given wallet address? See, yes, there is. Okay. See, we've got this command up here. Where is it? So, client transactions get. So this gets. This is like a paging. So if you have a look in here, we've got the address that goes in. We've got an offset, so whereabouts in you want it to start at, and a limit. So that can be used for paging. So if we, for example, we do something like let's just put in 100, for example, and start, and we'll go something quick. Oh, I won't put it in here actually, sorry. So what does this take? This takes in the sealed transactions. So come on. Kind of like something like this, huh? Oh, it's already got a break in there. Let's hope that works. I don't think I got 100 transactions in that wallet anyway, but I think it's, I think it's taking a while to get it. 100. It's making a few different calls. I might just limit this down to maybe 20. Try 20. And of course you can put in the count. You can put in the count here, something higher, and yeah, so right. So you like I'm saying, you can do a lot of it. There isn't actually a method to get every single transaction, like by default. There isn't a method to get every transaction, but um, it's just got transactions get. This is I think this is like the only method where you can really get every transaction for a wallet address. You just have to use paging to get all the entries. So you'll have to keep paging, looping over and using this transaction get until you get every entry, until you only start returning back null entries. And once you get your first null entry, then well, you know that it's come to a limit. But I guess if you didn't know, see, I coded that for you, because if you didn't actually, if you try to find it and you couldn't actually find there was a call in it, well, there is actually a call in it, but you just have to page over it. You can actually return everything back straight away. Everything's public at the moment, so there isn't any way to make your transactions private at the moment anyway. So it isn't. I don't think credits is going to go down the road of something like Monero or something with anonymous transactions and stuff like that. I'm not 100% sure. Like, I'm not part of the team. I'm just uh, one of the community members. But I guess they can answer that for you. Does anyone else have any questions? Or anyone want to see how to do a particular API call or anything like that? What is my favorite feature? Um, as an API feature or a feature of Credit's blockchain? Don't mind either. Um, well, I guess all the features that Credits is kind of known for, their autonomous smart contracts or their goals on trying to achieve 1 million transactions per second. Those are all big things that no other blockchain company has yet to achieve. So the performance of the transactions, what they're currently getting, their TPS test, that's quite impressive. So if they can get like 100 transactions per second and it's stable, well, that's really big in my terms. And I think you'll be seeing a lot of people using a lot of people building games and stuff with credits since it's so fast. Like board games. I was thinking about building. There's a competition, a hackathon coming up with credits. I was thinking about building like a decentralized snakes. I was going to call it snakes and credits instead of snakes and ladders. But and yes, if you guys don't know, there's a hackathon that credits is also holding, where if you win, I think the prize is like what, $10,000 or I mean, something like that. My favorite feature is this is the only blockchain as of now which we can do synchronous calls to blockchain, meaning we get instant response about the transaction. Um, Yeah. So I was doing a little test earlier. So what I was doing is I was sending a transaction, and then I was just waiting for it to be added into one of the blocks, and then uh, trying to validating that it actually went through by finding it in the block. So I was actually waiting for it to be written. I also really like that credits. It's they've built everything from the ground up with all their kind of consensus, and it's not like the let me say like credits is quite a unique project. It's not another kind of Ethereum fork with an additional feature where they raised $20 million. Like the credits built is building their application from the ground up, and that's what I quite like about it. Like I see it so silly that there are some projects out there that are pretty much just Ethereum fork, and they've just added one feature to it. They added sharding or something to it, Ethereum fork, and they've been able to raise so much money for it. It's just ridiculous. And that's one of the reasons why I really like it as well. Anyone else got any other questions or if you want me to show you anything, or if I've rushed something. I was a little nervous earlier, so if I rushed over something and you want me to go back over it. How do the verifications work on the blockchain? All right. Oh, well, so um, I'm not 100% sure on how credits handles it 100%, but you'll have something like this. So this is how how a blockchain normally handles it. You have a transaction, and you generate a signature for it, and when you send it through, the node or whatever will validate to check if that transaction. Well, the node will try and re-sign it with the exact same signature, and as a public address. Sorry, so the 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 node will generate a signature from it, and the and we generate a signature here. We send that signature over, and if the node compares that signature is the same, and all the data is the same, the signature is the same, well then it's validated that it's actual real transaction and wasn't something faked. So you do need the private key to sign the transaction, and the node will use your public key to make sure that it's a valid signature. So that's pretty much how they do it. It's yeah, they use the signature to verify that it's a real transaction. And I'm guessing credits. I'm not sure exactly how credits handles that. I'm guessing they handle it by having a node check to see if it's valid, then passing that transaction on to other network nodes, and then those network nodes also validate the transaction with the signature. So I think, how does it stop the double spend problem? So I'm not 100% sure. Like, I'm not a developer at the on the credits team, so I'm not sure what they do in the background. They do use the ID field to prevent against relay attacks. So since you got an ID in here, unique ID, I guess they can. I guess they check to see if a signature matches up with another transaction signature in the blockchain, and if two of them match up, well, then they get rid of the other transaction to prevent relay. So there is a minimum of nodes to confirm the transaction. Is there a minimum nodes? There has to be a minimum amount of nodes for their consensus to work. but I can't really comment on the minimum nodes to confirm the transaction. I don't know if that comes into play with it as well. You might have to probably submit that as a question for the developers. Yeah. I cannot comment 100% on that one. It's probably something you need to ask the actual team on the architecture of how that works. Like I know that in how the consensus works in general, but deep down into those points like that, I haven't done a massive amount of research to look at those fine-grained points. So there's they got things like they got like trusted nodes and I forgot all their node naming convention, but there's like trusted nodes and main nodes. I think it goes something like this, okay? I think you send a transaction to a node, and then that gets sent to a few trusted nodes, where the trusted nodes then validate if that transaction is correct. And then if it's correct, then it's confirmed. Trusted knows that any round must be 3 and less than 10. Yeah. I think Surya can. I can't see your name, sorry. Any other questions? Any other questions, guys? Is there anything that I've so I think there's some specifications to become a trusted node. Say the speed of your network, the speed of your computer, and also if your computer's like a performant enough, then you've got a chance of becoming a trusted node in a round. And yeah, trusted node in a round. And I think trusted nodes, they've got some kind of system like the trusted nodes. You can't send a transaction to a trusted node. Only the main nodes can send a transaction to the trusted node. Yeah, well, that's what we tested prior anyway. So you'll randomly become a trusted node. Ah, okay. They will verify the transaction. There will be 100 nodes for each round. One of these a main. Okay, it's at the main node. Yeah. So you can't send transactions to the main node, but all the other trusted ones. Any other questions? Yeah. I guess if you want more in-depth detail to how the actual credits blockchain actually works, like more fine-grained detail, you should actually go on the credits website, credits.com, and have a look over their white paper and their documentation on there. Any other questions? API questions, developer kind of questions? I don't think I'm the best person to ask about the architecture at the moment. I just know like the in general kind of to become a trusted node, you need to send a hash of your whole blockchain, meaning okay, yeah. Some more questions? Any more questions, guys? Any more questions? No questions? All right. I'll wait another minute for any other questions or anything, and then I might switch off the stream. Unless you want me to go over anything I might have rushed. If you're unsure about how to actually connect something up, how or what will you add to it? So they actually just updated their API yesterday. So I was previously using an old API a few days ago to make my demo, but I did have to switch over to the new API. So it is constantly being improved. There's methods constantly being added to it, more improvements. I'm not sure exactly on what API methods they yet to add, or if they're yet to add any. What would I add to it? What would I add to it? See, I'm not sure if at the moment I would add anything to it. There are some little things you can add to it, but you can still do it anyway with the current API. See, anything, if you can think of any situation like that you might want to do in the blockchain or anything, well, if you're unsure about it, well, I can say how I would probably do it if I was trying to do it. Yeah, there are some little things like how earlier I showed you with that kind of paging demo. Maybe there are some little things like there is no kind of client. If you go to transactions, there's no like transaction count. You don't actually need a transaction count, but that's just, I guess, you don't need it because you can already page over all the transactions and find it anyway. Yeah, but you can add like little things like that if you want to get picky, but I'm not sure what there's still to add, but I know they are working on it constantly. They've already made quite a few API changes, and the good thing is when they do change it, if there are any breaking changes to it, well, you need to it's not too hard to swap out the new parameters or, and there is one little thing like that if you have a look at the, where is it? Let's just so this won't work, but if you do have a look at there is this ID field. So the ID field is the index and the pool hash. So every transaction that gets created on the blockchain, its ID will be the pool hash, and the pool hash is in a base 16, and the index is what position in that pool it comes. So your ID is made out of the pool hash, appended with a dot, full stop, appended with the index that's also incremented by 1. So they don't use 0 as the first index. They use 1. That's one little thing I had a look at. If you understand that. But the pool hash is base 16. So if you have a look over here, it's just that byte array converted into base 16. Yeah. So I'll actually go into one. So the pool hash, the ID is the pool hash, and then that's the index of where it appears in the block. And it might appear actually in here as 0, starting off at 0. If it's oh, you need to increment it by 1, so the index should be the index plus 1. It doesn't start at 0, so index 1 and pull hash, and that makes up the ID of a transaction. So that just might be something if you get a bit confused about that, because I was having a little look at that the other day. Any more questions? And yeah, the credits team probably has more information on what kind of new API calls that might still be added, or what they're going to improve. And this part's just the Apache Thrift library. So the references, you need to make sure. All right, here's a biggie. When you're installing, if you're using C# and you're installing Apache Thrift, it's not this one. So this is so this is the correct one, Apache Thrift. There was one other one like Apache. See this one. So you think, oh, okay, I'll install this one, Apache.thrift, and it's even by the Apache Software Foundation. Oh, it says it's a custom build actually, so maybe that's why. But Apache.thrift, I thought this was the actual library, but that's not it. You just got to type in Apache Thrift, and this is the official. Yeah. So you're going to make sure this is installed, or these won't work. And yeah, I use chaos for the chaos.nacl for the signature signing, and I think that's it. Is there any other questions? Any other questions? I like answering questions if I can answer them. And remember, if you're trying to connect to your node, and you're connecting, you found the IP address, you're connecting over 1990 the Thrift port, you just got to make sure if you're not connecting, you just got to make sure that your node is allowed through the firewall to accept connections, these connections, and make sure if you're behind that, you port forward and map the port 9090 to your internal IP. Yeah. And that's kind of what that's what I've done on this. So this is actually a Google Cloud VM that I've got. So I just generated that, and this is what I also use to run my node. So I got a Linux node running here. So it's just running in the background. So it's syncing at the moment. All right, I'll wait one more minute. If no one's got any questions, I'll hang up. Hopefully I don't rush anything too bad. Hopefully I can't see any questions coming in. Anything at all? I think next week there's gonna be a different tester, and he's gonna go over smart contracts for you guys. So I'll probably create a smart contract and show you how it works. So that'll be interesting to watch. So make sure you tune in for that. Because the name's Deals M something. I can't say the last name. I think you robbed a judge. Alright, closing off in 10 seconds. Thank you guys for watching. Hope you learned something. And if you don't learn something, if you're still confused about something, or if I don't go over something that you think you have difficulty trying to connect up to, just let me know. There's also, if we have a look at back at the CS API, credits did actually export the JavaScript files if you want to use Thrift in a web page. So if you want to create some kind of D-app website, then you can just add these JavaScript files and do the exact same thing I was doing in C#, except in a website or in Node.js or anything like that. And yeah. So make sure you look over that. Make sure you have a research of Thrift. If it sounds complicated, it's not actually as complicated as you think. Maybe I just made it sound a little bit complicated, but also the API description. It's quite good to see the methods and the parameters. You probably don't actually want to look at this because this is the kind of the Thrift signatures. So I8's just pretty much an integer. Oh, sorry, a byte, and then the I32's an integer, 64 a long. Oh well, I guess yeah, fraction, but it's a long. It's the fractional part. Yeah, but I'd say the best thing to look at to learn the API is actually go into here, go into API, and here's a list of like all the signatures of everything you can call in the API. And I assume that the API smart contract methods, that they'll probably get more, probably go more into them in the later webinars. Yeah. Alright, thank you for watching, guys. Have a good night or day, wherever it is. See you later.